As we get started, I just want to make sure that we're clear about what the symbols are. Q is heat. It's measured in joules. It's whatever the heat is for the set of circumstances that's causing the change in energy. Delta H is energy or heat under some specific conditions per mole of whatever caused the energy change. So you got to take the Q and divide it by however many moles caused the energy or heat to change. It's called enthalpy then. Q is heat. Delta H is enthalpy. You might see the enthalpy of a reaction, however much energy per mole of material in the reaction caused it, or enthalpy of solution, however many moles got dissolved in water that caused a temperature change which was related to the heat, or or enthalpy of combustion, or heat of formation. But you want to know how to solve a particular problem. Let's say we're going to dissolve 35 grams of some solute, and let's put it in 75 grams of water, and we're going to make a solution, and we're going to have a temperature change, and that would be final temperature minus initial temperature. Okay, let's say we started at 25 degrees Celsius and it wound up at 35 degrees Celsius. That difference would give us a 10-degree temperature change. So those are some of the variables that we start with. The other variable would be specific heat. And for water, that would be 4.18 joules per gram of whatever we have per degree Celsius, based on the equation that the heat is the mass that changed temperature times the specific heat of the situation times the change in temperature. So for this particular problem, we have 35 and 75 grams changing temperature. So that's the mass that I want to include. So that's going to be what? 110 grams, and that's my mass, and my specific heat is 4.18, and my change in temperature is 10 degrees Celsius, and so I do the math. So the fact that I took 35 grams and dissolved it in 75 grams of water and it changed temperature, I got a total heat of 4598. So now I need to find the heat of solution, the enthalpy of solution. And all that means is that I'm going to take the heat that actually happened under this set of circumstances and divide it by the moles of the stuff that's dissolving that caused all this to happen in the first place. I never identified what the solute was. Let's just pretend it's sodium hydroxide. This is not going to be an accurate set of circumstances. I'm just making up something I know that would make the temperature go up. And I know sodium hydroxide, if I dissolved it in some water, would. So I need to take my 35 grams of NaOH and I need to change it from grams to moles. I know that 1 mole weighs. So pretending this is sodium hydroxide, my 35 grams of sodium hydroxide, I know that 1 mole of sodium hydroxide weighs 40 grams. That's the molar mass. And all I did was change grams to moles. I know that 1 mole weighs, oh, wait a minute, I can't read my calculator, 0.875. 0.875 moles of solute caused this temperature change. So when I go back, and I'm going to combine that with Q, and I'm going to divide that by moles. That's going to give me my heat of solution. And that means that was 4598 joules divided by 0.875 moles. And it's dark and I can't see my calculator. And that's going to give me my joules per mole heat of solution. And that's what you're being asked to do And I know that's not the answer you're going to get for sodium hydroxide because I just made the problem up. But it's still how you solve the problem. And it's still 40 grams. But this is not the data, the 10 degree temperature change and the 35 and 75. Those are not the numbers you're going to get from your lab. You're going to take those three things from the simulation, and those are what you're going to use in this equation. Then you're going to do the stuff in green, and that actually is the molar mass of sodium hydroxide to get your heat of solution. And that's what the first assignment is. Hope that helped a little bit. Have a great night and be in touch if I can be of more assistance.